In this lecture, we will study 5 numbers summary and box plot. The last two topics from chapter number 2. Right. So the 5 number summary, we're not going to study anything new in this summary because all 5 numbers we will study in this portion. We have already studied them. The numbers are minimum number in a given sample, the first quartile Q1, the second quartile median Q2 or median, this one, and Q3 third quartile and the max value. And in our last lecture we studied how to compute the first quartile and the third quartile. In lecture number 20 we studied how to compute Q1 and Q3. And in one of our previous lectures, we have already studied how to compute median in a given sample. And of course, we know what is minimum and maximum number. If we sort numbers, the first number, if we sort in increasing order, the first number will be the minimum, the last will be the maximum. That's simple. And if the curve is of mound shape, it's of a normal shape, 25% of the measurements will be between minimum and the minimum number and the first quartile. The 25% measurements will be between the first quartile and the median, and similarly 25%, approximately 25% measurements will be between the median and the third quartile, and in the last part, that is between the third quartile and the max value, we'll have the last 25% measurements. So these 5 numbers are easy to calculate, and let's move on to the box plot, the today's topic. Right, the box plot is used to detect skewness in data. If we have some outliers in the data, we can very easily detect those in a box plot. Before this, we have studied dot plot that also works the same in a similar way, and it is also possible to detect outliers using the dot plot too. So let's see what this box plot is and how is it constructed. Right, so things that are required to construct a box plot are these 5: the median, the first quartile, the third quartile, and of course the IQR. IQR is the interquartile range we studied in our last lecture. It's the difference between the third and the first quartile. Right, it's not a new thing, it's just the difference of Q3 and Q1. And upper fence and lower fence. Upper fence is Q3, the third quartile, plus 1.5 times the IQR. The lower fence is Q3 minus 1.5 times the IQR. And of course, 2 more numbers, the minimum number and the maximum number. So this is the whole stuff that we need to draw a box plot. The minimum number, the maximum number, the median, the first quartile, the third quartile, and that's all. Everything else is computed using these 5 values. IQR is computed using Q3 and Q1, and upper fence is computed using Q3 and IQR. Lower fence is also computed using Q3 and IQR. So you need these 5 unique numbers to construct a box plot. So let's see how is it constructed. Graphically, it's like a box. This is the box. The box has a lower limit and upper limit. The lower limit is Q1, the upper limit is Q3. The lower limit is the first quartile, the upper limit is the third quartile. And we have one more line in the middle that may not be exactly in the center, but that is at a value that is equal to the median. And we have 2 whiskers, 2 lines, one on the left and the other on the right. One on the left, one on the right. The length is proportional to the distance between the first quartile and the minimum number in the data, this one. And the length of the right whisker is called whisker, WHISKER. Whisker. So the right whisker, the left whisker, and the length is proportional to the length of the left whisker is proportional to the minimum is equal to the difference between the minimum and the first quartile, and this length is equal to the difference between Q3 and max number. And of course, lower fence and upper fence computed using these two formulas. So this is the complete box plot, except the static. What the static is? This static is the data point that is beyond upper fence. If we have a data point that is larger than the upper fence, computed using this formula. If we have a data point in our sample, a measurement in our sample that is larger than UF, upper fence, that will be marked as a static. And what would that static mean? That means an outlier. Therefore, it is marked as an static. This is an outlier. Right, so outliers are marked as static if they are any. And whiskers are line. I have already explained whiskers. So here's a small example to better understand what this box plot is and how to draw it for a given sample. Given this sample containing how many measurements? 1, 2, 3, 4, 5, 6, 7, 8 measurements. The first step would be, of course, sorting them from in an increasing order from the smallest to the largest. Right, so of course the next step would be the 5-number summary, because everything is computed using these 5 unique numbers. And is 8 because your 8 numbers, the minimum is 260, the max is 520. Two of them are very simple to calculate. Oh, in fact, you don't have to calculate, you have to just observe. And the remaining 3 are to be calculated. We know that Q1 in our last lecture we studied the first quartile is computed by first computing its position. Position is 0.25 times n plus 1, n is 8. Putting this n here, 8. 9 times 0.25 gives us 2.25. So Q1 is 292.5 because Q1 is 290, the number that is at position 2, this one, 290, plus 0.25 times the number at position 3 minus the number at position 2. So this computing this Q1, right, it's simple, and we studied this in our last lecture. Similarly, we can compute Q2, that is the median. First we compute its position, 0.5 times n plus 1, and then the median itself, and then the position of Q3, and then the Q3 itself. So it's simple. We studied in last lecture how to compute this Q1, Q3, and of course the median. And the max is 520. So IQR computed using Q3 minus Q1 is 47.5. That's the number, IQR. QF, the upper fence, would be Q3 plus 1.5 times IQR. LF would be, the lower fence would be Q1 minus 1.5 IQR. This F is fence, the limit, fence, upper fence, lower fence. So the box plot would be, the left line would be the Q1 is 3. How much? Q1 is 292.5. It's not 300. It's 292.5. Just before 300. Q3 is 300 and something. The right limit is Q3. What is Q3? 340. Right, just before 350. This one. And the median, the center line is median. Median is, how much is the median? Well, where's median? This one, 325. 325. So this is median, Q2, the second quartile, or median, 325. The left is the minimum number. The left whisker is the minimum number. So what is the minimum number? It's 260. 260. So it's stretched up to 260. So this is the minimum number, MIN. But there is no whisker from the right side, from Q3, from the right side of this box to the max number. Why? because what is the max number? The max number is 520. And what is the upper fence? UF. UF is 411. 411. So if you draw upper fence 411, it's drawn usually with a dotted line. So this is your upper fence. So we have already studied that if a point is outside the upper fence or it is before the lower fence, it's called outlier. So this 520 point, is an outlier. And what is the point that is before 520 in our ordered list? Before 520 is 340. So we can draw a line from this right side Q3 to 340. So that line won't be there because Q3 it is itself 340. So we cannot draw a line from 340 to 340. Q3 is 340. So we cannot draw a line from 340 to 340. Therefore, we don't have a right whisker at all. If this point won't be an outlier, if this would be inside this upper fence, we would definitely draw a right whisker from Q3 to that max point. But the only max point, the only point that is greater than Q3 in this case is this outlier that is beyond this UF. So we don't have a right whisker at all. That's an interesting example. So if there are more examples in the book, you are welcome to solve. You are encouraged, in fact, you are encouraged to solve more examples of boss law so that you can understand the concept well. So there is a question, why no right whisker? I have already answered that. No right whisker because there is no number greater than Q3. In fact, there is one number, but that number is an outlier. So we don't have a right whisker at all. So that's all for this lecture. And with this lecture, we have finished chapter number 2. And from the next lecture onwards, we will be moving to the next chapter. Thank you.